Alrighty, did everyone get a note packet? Yes, ma'am. Oh, yeah. I'm sorry, Sarah. All right, so for those of us that have finished all 3 parts of the last unit test, okay, the unit circle part and then the 2 like calculator, non-calculator sections, the grades have been entered, so you can check and see how you did. You're not going to get them back, though, until everyone can make up theirs, okay, but you can see how you did online. That test you took yesterday was the very last unit test for this year, okay, so there's going to be no more tests. I can see the fist pumps and the smiles already. But we do have one more quiz, okay? And we still are going to turn in some homework. I was hoping, I always plan more for a school year than probably what's necessary, just in case I get a really quick group of kids. Who knows how much we can actually get through. So my hope was to get through 2 more units. They were going to be short units. But obviously with like 2 or 2.5 weeks of school left, there's no way we're going to be able to do both of those. So what I did is I took what I feel to be the most important sections from those units, and we're going to cover those these last few weeks of school. So if you look at your cover page for this very last unit, okay, I guess we're going to have 2 units merged into one. We're only going to take a look at 2 sections from graphing trig functions. Okay, we're still talking about trig. And we're going to take a look at 2 sections from analyzing trig functions. Okay, so a little bit of both. At the very end, we're going to have a quiz, and that's it. Okay, so a little bit of graphing and a little bit of analysis. Before we can actually graph trig functions to see what they look like on paper, we need to talk about some terminology or vocabulary words so we become familiar with certain properties of these trig graphs. So what we do today, and maybe a little bit of tomorrow, you're not going to see any trig at all. Okay, no sine, cosine, tangent. Some of us are probably going to be very happy about that. But we're going to be bringing it back, okay, later this week. What we're going to talk about are periodic functions. Not sure if you've heard of that phrase or term before, but when it comes time to graph trig functions, they're classified as periodic. If you've heard that phrase before, can someone tell us what they think it might mean? A periodic function. Maybe you can take a look at the graphs down below as a little hint. Yeah? What do you mean in a row? A sequence or a pattern? Yes. Okay, so if you take a look at the graphs down below, notice how the graph essentially repeats itself after so long. Okay, you have the same piece being repeated every so often. So that's what basically a periodic function is. And we'll see what the sine, cosine, and tangent graphs look like later. Okay, they're periodic as well. But these are just examples of periodic graphs. These are not trig graphs. Okay, these are just other examples. So for us, we're going to define a periodic function as a function that repeats itself after a certain interval. So you're basically taking a chunk of a graph, a section of a graph, and repeating it over and over and over and over again. Okay, periodic. It repeats itself. Because we have a periodic graph that repeats itself, we have certain properties that are associated with periodic functions. We're going to talk about what a period is and what an amplitude is. Maybe those words sound familiar from a science class. I don't know if you've ever taken meteorology or maybe like an earth science where we've talked about amplitude or periods of waves, like in terms of wavelength. But this is a very similar concept. So if you we're going to use this one as an example. Can you highlight or draw, perhaps, the section of the graph that's being repeated? What you highlight could be different from your partners or who's sitting next to you. Okay, I'll show you why in a second. Maybe some of us would highlight this section as being repeated. Can you see that? Can you visualize it? Okay. Instead of highlighting that section, someone else might highlight this one. Isn't that technically being repeated as well? Okay. So whatever you visually see as the chunk of graph that's being repeated, it could be different. Okay, but it's still repeating itself nonetheless. So if you were to highlight the section of the graph that's being repeated, okay, the length of that section is referred to as the period. Okay, how long that original chunk of graph is that's being repeated over time. So we'll say the length of the interval that the original, for lack of a better technical phrase, we'll say chunk. Okay, the length of the interval that the original chunk has. Is has a preposition? You're not really supposed to end a sentence with a preposition. This is an English class, so we're not going to worry about it. Okay, the length of the interval that the original chunk has. Okay, how long that is. Amplitude, on the other hand, instead of looking at length, okay, how long something is, we're looking at height. Okay, the height of the chunk. Now, in this chunk that you might have highlighted, could you draw a line through the middle of it? Realize how that would, in this case, be the x-axis. Okay, that middle line, bless you, is what's referred to as the baseline. Okay, the middle of the chunk that's being repeated. And this is what's pretty important because at first glance, some of us might think the amplitude of this red section is 1, 2, 3, 4, 5, 6 units because that's how high the whole chunk is. Okay, that's not how amplitude is measured. Amplitude is measured from the baseline, okay, the middle of the graph. So in this case, the amplitude would only be 3 units. Okay, it's not the height of the whole thing, it's the height from the middle, okay, or that baseline. So we'll say the height of the chunk measured to the baseline. Right, so with those 3 terms, we're going to try to go through some examples of graphs. First of all, determining whether they're periodic or not. Okay, do they repeat themselves over time? And possibly we can figure out some characteristics like domain and range. Let's throw back to the beginning of the year, and then we'll try to practice period and amplitude. Okay, so let's go ahead and pretend like we didn't look at this one just yet. Okay, let's try to determine, is this graph periodic? Could you highlight a certain section of the graph and that section would repeat itself throughout the graph or over time? Would you classify this as periodic? I would say so. Okay, so if that's the case, I would try to highlight the section of the graph that you think is repeating. Remember, bless you, yours might be different than your partner's. Okay, whatever chunk you think is repeating itself, go ahead and highlight it.
Excuse the interruption. At this time, I need those students taking the Keystone test to report to your testing site. All students on the list for Keystones must report to their testing site. Thank you.
All right. Let's go ahead and try to determine some other characteristics. What about the domain of this graph? I'm not just talking about the domain of the little chunk. I want the domain of the entire graph. How far left or right does it go? Yeah?
Would it be negative infinity to positive infinity?
Yep, it would keep going. We could probably assume that there's arrows on the end. Not that the arrow is going to go infinitely up or infinitely down. Okay, the arrows in this case, since it's periodic, just means that the pattern is going to repeat itself. But it will go forever to the left and forever to the right. What about the range? How far low to high does this graph go? Yeah? Perfect. Okay, again, we could put arrows on the end, but since we classified this graph as periodic, the arrows do not imply that it goes up and down forever. The arrows in this case imply that the pattern repeats itself. Do we see the difference? Arrows at the beginning of the year kind of meant infinities. Arrows now just mean that the pattern repeats. Okay, slightly different. What about the period? That little section of graph that you highlighted, how long is it? How many units? Can we count? We go from here to here. What's the length of that chunk? Yeah, 4 units. All right. And then what about the amplitude of this periodic graph? Remember, that's measured from the baseline, okay, the middle of that chunk. Yeah, 3 units. Good. All right, let's try another example. Take a look at the one at the bottom. Can you highlight a certain section of that graph that repeats itself over and over and over? Remember, your section might look different than your neighbor's. Are you able to highlight something? Okay, if you are, then it's periodic. Okay, so let's see what you may have been able to highlight. Some of you may have gone from like high point to high point. Okay, that section repeats itself. Maybe some of you only included the little hump and then the big hump. Okay, that pattern repeats itself. So there are different chunks that you can highlight. Again, it might be different from your partners, but this is periodic. All right, what about the domain of this periodic graph? How far left or right can it go? Yeah. Perfect. All right, range. How far low to high? Yeah. With brackets, perfect. All right, so that little chunk that you highlighted, how long is that chunk? What's its period? 6 units, good. All right, and then the amplitude, measured from the baseline. You got to kind of find the middle of your graph. If we go from -2 to +2, the middle is probably the x-axis. So what's our amplitude? Yeah? 2 units, good.
If our baseline isn't the x-axis, should we just like count how much it is total and divide by 2?
Yeah. We're going to start to see some of those. Good question. We're doing okay so far? For the terminology, the characteristics? All right, let's keep trying. Yeah. Yes. All right, what about our next one at the top of the page? Is it periodic? Can you highlight a certain chunk of the graph that exactly repeats itself over and over and over? Unfortunately not. Okay, so we'll say no. If it's not periodic, we'll give a reason. We'll say because the graph does not exactly repeat itself. It does have a pattern, okay? It does have this jagged pattern to it, but it's not an exact pattern that's repeating itself. All right, what about these characteristics though? Can we figure out domain and range? How far left and right? Yeah? Perfect. All right, can we think about range? Yeah? Okay, so with a picture given, it has -4 to 5, right? But if we were to repeat the jagged pattern, wouldn't this one go down even lower? And then it would go up even higher? Can you see that? So what would our range be? If it keeps going lower and higher after every cycle, I guess. Yeah? It'd be in parentheses. Negative infinity to positive infinity. Good. All right. It is not periodic because we said it's not exactly repeating itself. So it should not have a period, which means it should not have an amplitude. Okay, those two characteristics are only for periodic functions. Okay, graphs that repeat themselves exactly. All right, what about the next one? Is it periodic? Can you section off a piece that repeats itself? Yeah. Yes. All right, maybe this one right here. Those vertical lines you see in there are asymptotes. I tried to make them dotted. I guess it might be a little hard to see, but those repeat themselves as well. All right, now, can we try to think about the domain? How far left and right does this graph go? But do we have any x values that we cannot include? We kind of have to skip or jump over. You have an idea? Yeah. We have to skip over all the asymptotes. That's perfect. Okay, so we're going to say we'll do all real numbers, but x cannot equal the values of those asymptotes because we don't have a graph at those sections. So can we kind of find a pattern with the asymptotes? We said it's periodic, so the asymptotes should repeat themselves in some pattern. It looks like we have an asymptote at 2, and then 5, -1, -4. Can we try to find some rule or pattern, maybe a little equation, that would tell us where the asymptotes always happen? This is when it gets a little tricky. Maybe you want to list them. Okay, x cannot equal -4, -1, 2, 5, and we'll do ... dots because those imply that it goes on in that pattern, both negatively and positively. Okay, if you can't think of a rule, maybe you just want to go ahead and list them. Yeah? Say it again? All right, so there's our rule. Okay, so this is what I meant by a rule. X cannot equal, let's see, pick any asymptote you want to start with. It could be -1, it could be 2, it doesn't matter. And if it's every 3, like Maddie noticed, maybe we'll go ahead and write +3n, where n is kind of the number multiple that you want to add on. So for instance, if we let n be 0, notice how x cannot be -1, okay, because that's where an asymptote is. If you want to let n be 1, we would have -1 plus 3, which would be 2. Okay, there's another asymptote at 2. If you want to let n be 2, we'd have -1 plus 6. And notice how that would be 5. Okay, so if you want to list them, that's fine. Maybe you can find a rule or a pattern to help you write a little equation that tells you where all the asymptotes happen. But I'll be happy with either one. Okay, whatever you are most comfortable with. What about the range of this periodic function? How far low to high does it go? Yeah. All real numbers, yep. So our little section that we highlighted, it will go forever down and forever up. All right, we said it's periodic, so that means we should be able to identify the length of the chunk that we highlighted and then the height of the chunk measured from the baseline. All right, so what about the period? How many units does that take up? Yeah. 1, 2, 3, yep. Okay, let's find the middle of the graph, which is again probably that x-axis. So measured from the middle, how far up or down does this chunk go? Yeah.
5 units.
Okay, so the graph goes up 5 units, but we can probably assume that there's an arrow on the top. So that would go up, yeah, infinity. Okay, so you could say the amplitude is infinity, or if you want to classify it as none, you could, because infinity technically really isn't a number or a length. But again, I can take either one of those. At least I understand, or I understand what you understand. All right. Do you guys want to try the last one at the bottom? Give it a shot. All right, were you able to draw a little chunk that repeats itself? Yes, shaking our heads. Okay, so it's periodic. Your chunk might be different than your neighbor's. Maybe you did one of those V shapes. Okay, let's talk about domain. How far left and right does this graph go? Are there any values we have to skip over? What do you think, Maddie?
All real numbers.
Okay, goes forever left and forever right. I like it. Are there any ones we have to skip over? The other one, the previous one, we had to skip over the asymptotes. Yeah?
The x can equal 1 plus 4n because as we 4 numbers, there's a n plus count number.
we have a point or a hole that's missing. Okay, so we got to skip over those discontinuities, holes, jumps, asymptotes. Okay, so all real numbers, but x cannot equal, let's see, based off of the graph, we can't equal -3, 1, or 5. Okay, that pattern would continue itself. You did a rule, though, which was awesome. What was your rule?
1 plus 4n.
1 plus 4n. Okay, so you can pick any of those numbers that you got to skip over, and notice how the numbers we skip over repeat themselves every 4 units. So that's probably where that 4 is coming from. Yeah.
Wouldn't you have to go the other way too? Like -1 minus 4?
Okay, we can do plus or minus maybe. Okay, we probably could have done the same thing here. Okay, plus or minus, depending on which direction you wanted to go in. Okay, great question. Looks good. All right, what about range? How far low to high does this periodic function go? Yeah?
Would it be -2 in bracket and 4 in parentheses?
4 in parentheses, perfect. All right, so the lowest -2, we have points there. Highest is 4, but that's where our holes are, so we need our parenthesis. Really good. All right, period. The little chunk of graph that you highlighted, how long is it, left or right? Yeah, 4 units. Notice how that was kind of the multiplier in our rule. Little pattern there. Kind of fits for the other one as well. What about our amplitude? What do you think, Maddie? How'd you get 3? That's good. The baseline's at 1. Okay, the middle of the graph. This time it's shifted a little bit. It's no longer the x-axis. Looks good. How do we do? Good? All right, let's go ahead and try kind of a free response type question for these periodic functions. So we're going to kind of connect everything together. The table below shows one cycle, okay, just one chunk of a periodic graph or a periodic function. The graph consists of line segments that are connecting the consecutive points. So we don't really have any curves or anything. This is going to be a jagged graph. Before we actually graph it, okay, based on the values in the table, how do we know that this is exactly one cycle? Take a look at the numbers. How do we know that this is going to repeat itself? Yeah?
It goes back to the y being 4.
Exactly. Notice how this beginning point we have starts at a height of 4, and the ending point ends at 4. They're beginning and ending at the same point, which means if you were to repeat the pattern, okay, they would line up exactly at that same height. So we'll say the y value begins and ends at 4. So the pattern will repeat. If it began at 4 and ended at 5, there would be no way for the cycles to repeat themselves or match up, because the beginning point of the next one would not match up with the ending point of the previous one. There'd be a jump or a disconnect going on. So they're matching up perfectly. All right. Identify the period and the amplitude. Again, it might be a little bit easier if we had a graph, but we're not going to do that just yet. We just want to take a look at the numbers in the table. So if this is one cycle, what would the length of that cycle be? How far left and right would that go? What do you think, Manny? How'd you get 7? Yep. All right. The first point begins at an x value of -4, and it ends at 3. Okay, so horizontally, you have a distance of 4 units and then 3 units. Altogether, that would be 7. So maybe we'll say -4 to 3. Okay, that's 7 units long. What about the amplitude? the height measured from the baseline. Can we first figure out where the baseline might be located? Where the middle of your graph is? Yeah.
Would be on,
How'd you know?
from -2 to 4 is 6 units. So half that would be 3, and if you go from the highest point, which is 4, down to 3, you get 1.
There you go. All right, so if you're looking at the, okay, so for the period, notice how we're looking at x values. How long something is, meaning left and right, kind of like the x-axis. Baseline, though, we're looking at a height, the middle of the graph. So that's signifying some y values. If we look at the y values, the highest we go is 4, the lowest we go is -2. The exact middle of 4 and -2 is 1. Right? So there's our baseline, but using that, we need to calculate the amplitude. Maddie, I forget, did you mention what the amplitude would be? 3. Okay, so from the middle, which is 1, the highest we go is 4, that's 3 units. Or you can think about the lowest we go is -2. That's 3 units away from 1. So our amplitude would be 3 units. Perfect. All right, so let's go ahead and graph some of these cycles. We'll go ahead and graph maybe the original one first, and then we'll repeat the pattern to see what this periodic function might look like. So we'll plot some points, -4, 4, 0, 2, and they told us that this is going to be kind of a jagged graph where we connect the points using straight line segments. All right, there's our first cycle. So that pattern is going to repeat itself. Let's go ahead and repeat it. Can we think about where our next point might be located if we go to the right? So we're going to start at 4. We got to figure out where this next point would be. So where would the point 0, 2 move to? What do you think, Maddie? 7, 2? How'd you get that? That's good.
I found the distance and x values between -4 and 0.
We can go ahead and use that period. Okay, we said the period was 7 units. Perfect. So everything is going to repeat itself 7 units away from the previous point. So if you start here and count 7, 1, 2, 3, 4, 5, 6, 7, we should plot that point. Let's do the same thing for the next one. We'll count 1, 2, 3, 4, 5, 6, 7. And then our last one, 1, 2, 3, 4, 5, 6, 7. I want you to do the same thing but going backwards, because this cycle can repeat itself forwards and backwards in terms of your graph. Let's see. So this time we're going to end here. We're going to work to the left. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. How are we doing so far? Periodic functions okay? All right. We're going to wrap up the last 2 questions tomorrow, trying to figure out how we can answer really tough questions, like what would the value at -77 be? Okay, but we'll see how we can use period, amplitude, all that stuff to help us answer those questions. And then, since we only have 2 left, we're going to get into the trig graphs tomorrow. Okay?